we will talk about a quick introduction to C++. And no, I'm not going to record the assignment 4 parts. We'll migrate to Discord so you can see my screen. Everyone can turn on your microphone to ask the questions. And yes, that's why I want you to be aware that it's not free solution. So it's going to be driven by you. And for sure, right? For sure, you can basically write whatever I wrote here on the screen, right? So please no visible status. I mean, come on. It's already like almost a solution for some of these function calls, all right? So let's come back to the content of this class, C++. The high level idea behind C++, right? It is simple. The motivation behind it is I want to be able to write C code, but with the concept of objects, right? Why objects? We will go through a quick introduction of object-oriented programming and like a quick recap from your Python class. One more note about C++ is if you see in the file in C, it will end with the .c, right? So you can tell that's a C file. If it's C++, typically it's either one of these two formats. It can be .cc or .cpp, right? In reality, as we have learned from the Linux part of the lecture, this extension doesn't really mean anything. It doesn't matter. It tells, right? One thing that it does help is when you see something .cc, you can expect that to be a C file. And the other thing is standard C syntax would work in C++, right? So you can write C code in C++. That would work. And now I'm going to start to tell the difference between C and C++ by beginning with this cout and cin. So we all remembered our old friend printf and scanf, right? What are they for? What do I use printf and scanf for? It is an input and output, right? Through the standard I/O. So if you see this word cout, basically this console output, these are basically standard output your monitor. You can now use cout to do printf and use cin as scanf. The reason why I brought it up is it does threw me off a little bit the first time I ever see C++ code because many people use cout and cin and I was like, hey, what's this? And so I ended up having to Google that a little bit. It's like, oh, okay, it's just standard input and standard output. And the way you use that, you can use redirection to redirect the and yes, standard : CL would get many people the first time they see it, right? But basically, you would do the cout and then redirect like hello, right? This would basically print the text hello in your monitor. Treat this as printf and scanf. It's just a different syntax and how you use it. All right. The other thing that different in C++, which is actually nice, is now we have Boolean. Yep, now they exist, right? They represent the actual binary value, true and false. So now C++ can differentiate between true and false, but you can still use 1 as true and 0 as false. Basically, non-zero is true, 0 is false. Everything that you use in C applies here. But now you can also create a data type called Boolean and represent the value true and false. Now C++ can tell the difference, right? What are the next major difference is the existence of object-oriented programming. All right, object-oriented programming. What is object-oriented programming? I'll use this example to kind of drive the design today, right? Because I have a cat, so I can create an object called a cat. So what can a cat do? What should be different properties of a cat? Can someone tell me what should be the property of a cat? It should have a fur, I guess fur color, right? It can purr, right? So that should be a function called purr. And also, yes, it should have a function, I guess, called, it should not return Boolean, because when you meow, you're not returning true or false. I guess you can say it's talking, right? So say talk, right? I will also add things like eat, sleep, right? So these are things that cats can do, right? And what is a cat? A cat is an animal, right? So you can basically have another class, which is animal. And most of the time, animal can also have a way to eat as well, right? And sleep, right? So in this case, you can say, hey, the cat inherit whatever you declare from animal. This is called inheritance. But is a little bit more unique, right? Where you have different color for the cat. It can purr, it can eat, which is defined in animal. It can sleep. It can also talk. Are there any animals that cannot talk? Can you give me an example of an animal that cannot talk or cannot make sound? Yes. How about fish? Right. So I guess I can have another class called fish, right? Where it can eat, right? Sleep. I guess blub 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 is a possible. Well, I mean, we don't hear that noise. We actually don't. Well, maybe they can talk. Who knows, right? But they can definitely swim, right? In this case, you have two different classes: the animal with the type cat, and another animal which has the type of class called fish. There will be two different objects, right? So this is basically a part of object-oriented programming. You can have an object in your program, right? In your program, that would behave in this more like hierarchical way. You have an animal. There are multiple different classes that can inherit from an animal. So you don't have to rewrite the same function over and over and over and over again on how does each of the animal eat. Basically, they'll go munch over whatever food they spot, right? That's how my cat work. I think that's how most animal work, including myself. I just spot food and I go eat them. Um, yeah. And then they can sleep, right? The way animals sleep is the same. They would just lie down and rest for a few hours, and you would wake up and walk around again, right? And then there's unique thing about cat. For example, would they be able to purr, right? They'll be able to talk, meow, right? I can create multiple objects from this cat class. For example, right? I have two cats. One of them is named Namtan, the other one is named Naomai, right? So I can create two objects, one called Namtan. The other one is called Naomai, right? And then these two objects would be both cat, right? And then I can actually call the function, right? I can call the function that say, hey, talk or eat or sleep, right? And I can also implement the way they talk in a different way. Because one of my cats is weird. Namtan is kind of weird when she talks. She would just do that's it. She doesn't meow, which I don't know why. But anyway, right? I can now implement the talk function for Namtan in her specific way, which is it would just instead of returning meow, right, like a normal cat, she would return rather than meow, right? So that's what I can do with object-oriented programming. I can make each object unique, right? And I can also make each class unique and the same at the same time. It inherit the hierarchical order of functions that are similar from the class that you inherit from. For example, animal, right? You can eat, you can sleep. Imagine, can I do something similar with C? If I don't have the concept of object-oriented programming, can I have something that would represent a cat, another type of data class that would represent a fish? Can I do that? I mean, is it possible? Yes, exactly, right? You can use a struct, right? And then you can tie multiple function pointers to a struct. For example, I can have a struct called a cat, right? And then I have a function pointer that points to the function called purr, talk, eat, or sleep. Will that be annoying to maintain? So which one is easier? It's going to be super annoying to do that in C, right? Because this concept is built to, in my opinion, it actually does improve what we call programmability a lot. Programmability is, as the name suggests, the ability for programmer to actually program. It also has some tie to like productivity, right? So in this case, with object-oriented programming, it's much easier to kind of like write and develop your code, right? So that's why C++ is actually popular. C is fast. C++ is also fast. And it's also object-oriented programming. So standard notion of object-oriented programming would exist in C++. You can have a class, you can have an object, method, constructor, interaction, and polymorphism. For more information, please refer to 2 additional classes in the future. One of them is called Data Structure and Object-Oriented Programming. If you look at Discord, there's a channel called DSOOP. That's the class. Another class is called Functional and Parallel Programming. So that's the class that typically I am the one teaching that class. Next semester, Ajahn cannot teach it because I'm actually like slightly on a maternity leave for next semester. So I'll be just covering the PCSA, the Computer System and Architecture class toward the end around like April. But these are the 2 classes that would kind of thank you so much. Yes. These are the 2 classes that that would kind of follow up on the concept of object-oriented programming, the concept of data type, the concept of polymorphisms, the concept of inheritance, and what does it mean to your program and to the language, right? Because as a computer scientist, we actually learn computer language as well. We are the interface between human and computer. So we need to learn the computer language and how do we build one? How do we build one, right? And here is the basic class structure for C++. Here is something that would define a class. Anyone here used Java before? Yes. So for those of you who used Java before, does it look like a Java program to some extent when you declare a class? Does this have something that looks really similar to what you saw earlier from Java? So yes, so that's a yes, right? And many other things here inside a function call, it looks like C. Inside your function call and function definition, this is like a typical C code, right? The way you construct a class, this kind of look like a Java, where you have a public function and public variable and a private variable and private function. What are the difference between public and private? Oh, wait, where? Oh, okay. Yeah, thank you for that. Yes. So don't forget the semicolon. Sometimes it actually will give you compilation error and it would be kind of odd looking. Thank you. So yeah. Uh, so what is the difference between public and private here? So what does private mean? Private means if I'm the owner, like if I'm this object, I can call the function, I can access the data, right? But no one else can access that attribute, right? No one else can access that attribute. While public, everyone can access the attribute, everyone can call the function inside the public declaration, basically, right? So that's the difference. Then there's a concept of constructor as well. Constructor is a way to let's say I want to create an object. Let's say I want to create a cat object, right? Then I would construct this cat, right? Everything. So the way the constructor works, the way you declare that is put in the class name followed by the inputs. In this case, is no input, right? So you can create this object without putting in any additional inputs. These are the code that will be run when this object is created. So you run this code when I create this object. And similar to typical object-oriented programming, you can have multiple constructors, right? You can construct with no input. You can also declare, if I have one input, it would call this point instead, right? It would take one input, do whatever with this integer input I, right? And with this, right? For example, what if I have this and inside this constructor, I have name equal malloc, size of char multiplied by 20. What do we have to do here? Now that we have malloc, what do we have to make sure we have at the end when I am done using this object? We should free, right? When you have malloc, at the end of the day, you have to free. How are we gonna free that? How are we going to free this? Right? So the answer to this is something, this is unique to C++. It's called Destructor, right? You can delete, yes, you would delete the object. But if you delete the object, the fact that you malloc, right? The fact that you malloc, you have to kind of clean that up. So when you build a constructor, most of the time, if you have any memory allocation, make sure you have the destructor. Destructor will be named the same way as constructor, but you add this tilde sign. Tilde sign means that this is a destructor, and you do things like free in here. This is to make sure that if you pair this up with the delete command, so there's a command called delete. Delete would delete the object by first call this destructor and then delete the object. So delete, let's say you have a class definition called test like earlier, right? And in the main function, you have new object called myTest and another new object pointer called myTest2, And then the keyword new would basically create the object with the class test, right? It would create the object with class test and make sure my test to point to that object. At the end of the day, you can say delete my test2. What will happen here? It would go and delete this object and call the destructor. So if you need to free anything, it would go and free everything needed that are defined in the destructor, right? This way you can maintain a multiple object. You can use pointer, you can use just a typical variable. And then when you are done using that particular object, it would call the destructor and make sure there's no memory leaks, right? That would allow you to ensure there's no memory leaks. And if you want to access the method, right? If it's a normal object, like this, you would use the dot, the object name dot for function that you want to access. If it's a pointer similar to struct, you can use this arrow sign, the pointer name arrow sign my function to access that function. All right, so that's how you can access the method inside the object. And then let's say I have something like this. I have the object that is named foo. Inside there's a variable called x, and then also there's an object called bar. Inside here is variable called x, and let's say they are of the same class. Right? How can you make sure that you can access this x, and not the X inside bar. To do that, we can use this double colon. Double colon is called the reference scope. The reference scope. So let's say X is defined in object called foo and object called bar. I want to be able to access X in here. So foo colon colon X means that I want to access the X defined in foo. Bar colon colon X means that I want to access X in bar. Foo and bar in this case are both object. All right, object, it can be the same class. So in this way, you can go and access all the public variable, including the private variable if needed, through the reference scope. All right. And the last thing before we are done with kind of the quick overview of C++ is something we call a namespace. The namespace would prevent name conflict. For example, if I want to declare multiple versions of factorial for different part of my sub-project in a much bigger project, right? Let's say I'm running a huge project, and people can define their own version of factorial. You can use a loop, you can use a recursion. When you have multiple teams working on a project, it's kind of like a good idea to define a namespace. A namespace, as it suggests, right? It's a different space where you can name things in a different way. So a names that are defined in a namespace, like a factorial function, for example, need to be unique. There has to be only one version of that, but you can create multiple namespace. To do that, you can say using namespace followed by the name for the namespace. This can be any name. So inside the C file, you can declare at the top saying using namespace and the name. It will tie that file with everything defined under that namespace. This is one of the really common things that happen in many C program and C++ program. This is what another thing that threw me off when I started to use C++ for the first time. Like, what is this using namespace, right? Basically, it would map whatever you have in the code for that file to use this particular name for the namespace, right? Then the last thing we want to talk about is called inheritance, right? I'm sorry. The last thing we need to talk about is inheritance, right? Inheritance is what we saw earlier when we had the cat that inherit from the animal, right? So let's say I assume there's an animal class with a string name, right? You can add additional string that can allow this particular class type, which is called a cat, right? That can talk. Instead, we just return meow, right? So in that way, you can create, right? You can create a new class that has multiple properties that are similar to animal, but then it can have its own unique flavor, which is the cat, right? And that's the concept of inheritance. And that's all. Before we leave for assignment 4 demo, which I'm gonna kind of show it on Discord. We have the new in class 12. Please, every one of you, if you haven't finished in class 1 to 11, these are almost 3 points. Finish it. It doesn't have to be absolutely correct. I just want to make sure you work on it. All right. In class 1 to 11, it will be due by this Friday. We will check by Friday. That's the deadline for in class 1 to 11. In class 12, that's due by next Tuesday. Recommendation for that is next Tuesday for sure. Why? This would give you study material, right? For your final. It cover virtual memory. So in class 11 cover caching, in class 12 cover virtual memory. Fun fact, both of them are from one of the quiz from this class. So you are expected to see something similar to these kind of questions. All right. Go and practice it for sure. It would also assignment 4 is another really, really awesome material for your final. I got a feedback saying once you did assignment 4, anything that are related to the caching question on the final is much more, much easier. So that's it. Now we'll go through some of the basic of assignment 4. We will transition to Discord. I'll stop the recording now and I'll post this later. There's a question. Okay, does 32-bit machine always have 2 levels of the page table? Because you didn't specify the ISA, right? Not really, but if we use the x86 ISA like Intel or AMD, the 32-bit machines from Intel and AMD that use x86 ISA, they will have 2 levels of the page table. Great question. The number of the page table level and how they manage address translation is defined. It's defined by the ISA. The ISA is the assembly language, the flavor of the assembly language, also including things like specification of the hardware that's provided in the ISA. The topic that we learned right before going into assembly, right? So the 32-bit machine that we assume, which is x86, they will have 2 levels of the page table as we learned in this class. So that's why I don't want to say strictly yes. It depends on the hardware specification, right? I can use a totally different design, but for most textbook purposes, including even with people who develop operating system, they would assume 2 level of the page table for a 32-bit machine and 4 level for a 64-bit machine. All right. Hopefully that answered the question. So almost always yes. Almost always yes, except when you design your own hardware. All right. So now, any more questions about the class material?